Today we're going to be modifying the carb for the built scooter motor to accept the stock throttle cable. It's not something I've seen done before, so we're going to have to work out how to do it. So this is the new carb. The issue is this is a different style carb to the original one. This is a flat slide or flat-ish slide, and the original throttle cable doesn't have enough free cable length on the end of it, and it's also got the wrong style end. So this carb here, you can see the shape in the end of it. It's supposed to have like the little barrel on the end of the cable is supposed to be going this way. The other problem is because it doesn't have enough free play, if we imagine this attached to there, and then put this inside the carb, all the way at closed throttle, the cable ends up being down inside the carb down here, whereas this little silver ferrule on the end of the cable should actually be sitting in the top of that. So our cable's sort of this much too short. So I think what I'm going to try and do is I'm going to make a small insert that goes in the top of the carb here so the cable can attach right to the top, and I think that should give us enough free play. So our piece that we're making needs to do a few jobs. This is the original one and we're kind of building a similar thing. What it needs to do is it needs to retain the needle in the bottom of the slide, so it needs some way to hold the needle down. The spring needs to sit in the bottom, but if you can see, if I slide the spring in now, you can see it here, it's not supposed to go that low. So that's what the original plastic piece did, it held the spring at the correct height, so we need to be able to hold the spring, but the spring has to be held down at the bottom, and we need the throttle cable to connect halfway up. So we're going to have to make something that can hold the needle, have the spring down, but then have a material further up to hold the throttle cable, and then it also needs to be attached to the throttle slide somehow. So I'll do a quick drawing. Okay, so here's the plan. This is the piece we're going to make. The throttle needle will sit on the bottom here. This is a 3mm hole up the inside, so this pin, like this piece insert we're making, will sit on the circlip for the slide, which is what we want. This outside diameter is turned down, so the spring will sit over the top of it. And then the 3mm hole that's up the inside that fits this in will also fit this end of the cable, and the very end has a 1.2mm hole, and we'll cut a slot down it. So we should be able to slot the cable in, pull it up till it hits the top there, so our cable's now higher. The spring will be down over the cable, over the top, so the spring is held at the correct height, and it should clear the pin at the bottom. And then once it's in the carb, what we're going to do is we're going to drill and tap a hole in through the side here, and put a countersunk screw in it, either that side or this side, and then countersunk screw into this, and that should keep it in place. So that's the plan. I'll start making it. So I'm going to be machining this part on the Myford here rather than the big Soviet lathe. The two pieces of aluminium I have are these two. This one's a much smaller diameter, but it's short, so there's not going to be much to hang on to. This one's bigger. I can hold on to it, but it's going to be wasting a lot of material, turn it down to 13mm. So I'll start with this one, I guess. It's a bit hard to get the camera in a nice spot just because there's stuff around the lathe and I need to stand in front of the lathe. But to start with, we'll just zero our tool diameter on the face. So we've got a 0 point. So all I'll do is touch it, take a small cut, set my readout to 0, and then I'll take a small cut off the diameter and we'll set it to 0. Okay, so the first thing we're going to do, following our drawing, we're just going to turn the outside down to 13.1mm. Because this is such a small lathe, if we're on the big Soviet one, we would do this in one cut. Because this lathe is small, we're not holding onto the piece of material by very much, we'll have to do it in a few smaller ones. I think it would also be nicer if we could run this at a higher RPM, but this is as fast as it goes, and I'm pretty sure this little motor wouldn't have enough torque to run it geared any higher anyway. I think this tool could also do with a sharpen, but it'll do. So this is the last cut, should land us at about 13.1. Normally as you're cutting, you'll measure it to make sure you're staying on track. Because this isn't a particularly precise piece of material, this isn't a precise job, I've just gone straight for the cut without measuring it, and we'll check how close it is once it gets to the end. There you go, 13.19, so we're 0.09mm oversized, which should be fine. Cool, so I just explained that without pressing record. I just took another 0.2 off this. It turns out this piece is actually a tapered hole, so it didn't fit all the way on, but now it fits all the way down. I don't have anything that can measure all the way to the bottom of a hole this deep, but we fit now, so now we'll just turn down the shoulder for the spring to sit on. So according to our drawing, the spring shoulder is 8mm diameter, 6mm deep. So our spring should fit neatly over that, and then not fit down the bigger part, which is correct. So the next thing I have to do now is drill a 1.2mm hole in the end of this. 1.2mm is pretty tiny, so I'm going to go in with this step drill, because this is the stubbiest drill I have. The problem is, because my tool wasn't set on center in the first place, there's a little nub in the middle, and so the drill bit's going to want to hit that little nub and then go off to the side. So I'll use this bigger drill bit just to get a bit of an indent there to get the drill started, and then we'll switch to the 1.2. The hard bit with this is the smaller the drill bit and the smaller the diameter you're using, the faster you need to run it. And this lathe is very RPM restricted, so it'll be interesting trying to drill a tiny hole like that. There's the little drill bit. I can see this just going ting and snapping off, but we'll see. Yeah, this would be nice if it was going about 3 times faster. There's our hole. We didn't even break the drill bit. So we have our piece now. The problem is we only have the front half of the piece and it's attached to this big lump on the back. So I don't have a small parting off blade set up for this lathe. So what I'm going to do is I'm just going to cut it off with the hacksaw and then we can flip it over and start machining from the other side. Wow, this has like no teeth on it. I think I need the other hacksaw. The biggest thing when doing this is you go really slow when you get to the end, because the last thing you want to do is slip through and cut into the lathe ways. Some people put like a piece of wood and stuff there, but if you're not retarded, you should be able to just not cut last bits super hard. So it's our little piece ready to go the way around. So the first thing we'll do is just face the end of it so I've got a good surface to measure off, and then we can face it to its final length. I just thought I'd point out, when we're cutting on the end of a piece of material like this, it's called facing, and if we're cutting down the outside of it to make it a smaller diameter, it's called turning. And then the whole process here is either turning or machining. It's not lathing. It makes you sound like a 4-year-old if you call it lathing. It's the same as when Americans call Legos Legos. Like, it just makes you sound like a 3-year-old. It's not Legos, it's not lathing. Turning, machining. One of those, pick one. So the final length we need this to be is 17 mil. When I measure it in its current length now, it's 17.7. So I can put it in, take 0.7 off, and then this piece is the length we need. We're ready to drill the last couple of holes in the bottom of it. So now that we're faced to length, the last thing we need is a 3mm hole drilled all the way up to match that 1.2mm hole we drilled. So I'll do the same thing again, start off with the step drill. So that's our hole finished, and with that, that should be the whole part finished. All we have to do now is cut a slot in it. Okay, so I've just cut the slot in the end of this with the hacksaw, and here's the throttle cable. The slot is just not quite big enough to get the cable through, and I don't have a file thin enough to get in there, so I'm going to set it up on the mill and machine the slot bigger. But the smallest end mill I have is 2mm, and the end of the cable here is only about, it's just over 3, so hopefully the slot's not too big and it pulls all the way through, but we'll machine it and hopefully I don't have to make another one. Well, that cutter broke almost immediately. Right, attempt number 2. Okay, looks like we had more luck that time. So there's our finished piece. The slot in it is a little bit bigger than I would like, but it is big enough that this can't just fit through. You can see if I actually slide it through, it then slots up inside and pulls on it. So what we'll do is we'll do a test assembly and put it in the carb and see if it actually all fits together now. So this little plastic original bit we don't need anymore. Okay, so I've just assembled this all. The carb is all the way closed, which means we've got enough cable length in there, and the cable's fitted properly on top of the carb. So the last thing I have to do now is attach that little aluminium piece I made to the carb slide. So now that we know the spring and the cable fits, the last thing we have to do is get this to actually attach into here. So what I was planning to do was drill a hole through it. But what I think I'm going to do now is, because you can see part of the little aluminium insert in the old cable slot down here, if I drill a hole for an M3 screw and put the screw in there, that'll stop it from sliding out. The only problem is this screw is too long, so I have to cut it shorter, but the head will still stick up out of here. So what I think I'll do is, I can't machine the head down because I'll lose the Allen key slot out of it, so I'll drill a countersink into here so the screw sort of screws down further into it, and then I think that will do the trick. So I'll head over to the mill and drill that hole. There you go. There's that with a countersink in it. I'll just tap the hole. So I had a slight hiccup. The original screw I had was actually an M2.5, not M3, but I drilled and tapped this to M3. However, I just found an M3 screw, and there was enough material that I could just machine the outside off it so it would fit, so that should be all good now. So just to demonstrate how it goes together, I won't put the spring in because the spring makes it hard to put together, but it does fit. So the throttle cable goes in here. Our adapter piece goes into the original slide. And then once it's in the slide, if I'm not blocking it with my fingers, our screw goes in. So we now have the throttle slide securely attached to the cable, and the original cable wanted to go in this hole, and our cable is now all the way attached at the very top here. So we've gained like 10 mil of throttle slide. Then our clearance in the carb looks all good. Oh, it's not going to be in focus. So the screw doesn't rub on the carb body or anything, and it looks kind of cool with the screw in there now. But that should be it. I will Loctite that screw just because if it rattles out, it'll end up going in the engine, so that's not ideal, which is it's kind of what killed the engine in the first place, not this screw, different one. But I think that's ready to go, so looks like it should work, hopefully. So it's all assembled into the carb. I've just got it hooked up to this spare throttle cable, but you can see it goes all the way to the closed position. If I pull the end of the cable with some pliers, we get our travel. It looks like it might not be opening all the way to full throttle, like it's sort of a couple of % short, but we'll see what it's like in the actual scooter instead of just with some pliers. And also, I'm not sure what this car is like full. Actually, even if I push it by hand, that's about as far as open. So I think we're good. But that's about the end for that video. Okay, so hopefully you enjoyed that. That was like a little machining project. I'm going to get the scooter out now and start swapping the engine over. So make sure you're subscribed. I'm aiming for 10,000 subscribers. I put a video out every Friday. The next video on the scooter should be a test drive. We'll see how this built motor with all these dodgy bits and pieces actually goes. So hopefully you liked the video. See everyone on the next video and have a good night. Goodbye. Or good morning. Depends on what time zone you're in.